Chapter 6, Lesson 3, Square root functions. So square root function is when the function contains a square root with a variable inside. They're also called radical functions. So let's take a look at how we can solve square root or radical functions. Alright, so we're going to graph, first we're going to graph this parent function here, y equals square root of x. We need to look for key points. Now, square roots. So key points we're looking for. What numbers can we take square root of? Well, I can take the square root of 0, and it gives me 0. I can take the square root of 1, and it gives me 1. I can take the square root of 4, and it gives me 2. I can take the square root, and again, you can kind of see we're just squaring this number on the right. 0 squared is 0. 1 squared is 1. 2 squared is 4. 3 squared is 9. 4 squared is 16. That's probably all the further you would need to go. Those are the values we're looking to try and get into that square root because we can calculate them. And they're pretty easy to calculate in our head. So those are our values. So we have our x's here and our y's. So x is 0, 0, x 1, 1, 4, 2, and 9, 3. So there, this is our parent function here. Okay. So you can see starting point here, and when I go from my starting point, I go over 1, up 1, over 3, up 1. And again, you can remember those two moves, you'll be able to graph 95% of the functions here. Okay. So this is very similar here to what we've done in the past with graphing. So let's take a look at this second graph. So now we're going to graph y equals the absolute value, or the y equals the square root of x plus 4. So again, we're looking for those values. So what do I need to get 0 in my square root? What number do I need? Well, I need a negative 4. If I get 0 in there, I get 0 out. If I can get 1 in my square root, then I'm going to look for a negative 3, and that will give me a 1 out. Okay? And if I can get a 4 in my square root, well, that means I'm going to put in a 0, and I'm going to get out a 2. So those are my graphs. So those are my values for my graph. So negative 4, 0, starting point. Negative 3, 1. And 0, 2. And so here is my graph. So you can see from this graph what's happening. Well, this graph originally started here at 0, 0. Originally started at 0, 0 and moved to the left 4. So this moved left 4. Okay. Our domain then, you can see not all x values are going to be included because anything to the left of that graph here is not going to be on that graph. So x is going to be greater than or equal to that negative 4. And my range, again, same thing, my y values, there's nothing going on down below here, so y has to be greater than or equal to 0 then. Okay. So let's take a look here at some rules. So just like before with our x squares, our quadratics, our absolute value functions, we have this kind of a guide. Anything inside is going left or right. So inside that the radical sign going left or right. Remember, it's opposite. Anything on the outside where this k is going to go up or down. And the numbers in front being multiplied is going to be a stretch or compress. Okay? If it's a negative out front, we're going to flip it across that x-axis. Okay? So let's take a look here at letter A. So in this graph, we're looking at left and right, so we're going left 4 for my starting point. So from 0, 0, I'm going to go to the left 4. 1, 2, 3, 4. There's my starting point. Now my original moves are over 1, up 1, over 3, up 2. Okay? So This 2 though is be my multiplier. So instead of going over 1 up 1, I'm going to take that 1 times 2 and I'm going to go over 1 up 2. And then I'm going to go over to the 3. Instead of being at 2, I'm going to multiply that by 2 and I'm going to go up to 4. So here's my new graph. And again, once you get a couple of those points on there, you can just sketch that graph. Okay. Again, if we're looking at that domain and range, the domain x greater than or equal to negative 4, y greater than or equal to 0, okay. All right, let's take a look at letter B now. So letter B is going to make us think a little bit here, okay? So first movements, right 4 up 3. So right 4 up 3, 1, 2, 3. So there's my first point. Now, again, my next point is over 1 up 1, and then over 3 up 1, okay? So there's, these green dots are my next 2 moves, okay, from the original graph, okay? So now, but here I'm being a multiplier by 1/4. Now I can't, it's kind of hard to tell. I could guesstimate and say, okay, well 1/4 is about right there, over 1 up 1/4, okay? I don't necessarily have to. If I went over another 1/4, then I'd be at 1/2, okay? So I can kind of just estimate those values when I'm graphing those, and so it's going to get really flat and almost like a straight line across there. So again, domain then x greater than equal to 4, the y greater than equal to, in this case, 3. Alright, let's take a look. We have a application type problem here. Okay. So after an accident, police can determine how fast the car was traveling before the driver put on his brakes using the equation. So they give us this equation here. Okay. V represents speed in miles per hour. F is the friction, and D depends on the skid marks in feet. Okay. So F, in this case, we're going to assume F is 0.6. Okay. So find the speed that skids. Find the speed of the car that skids 25 feet. So we're pretty straightforward. We're given this speed equals square root 30 times my friction 0.6 times 25. Okay. So I'm just plugging that straight into my calculator, and I get V equals 21.21, and again this is that miles per hour. So speed is 21.21 miles per hour. So that was pretty straightforward. Plugging it in, just plug it straight in the calculator, no solving, get my answer. But now what if I want to know, what if the car's going 35 miles per hour? How far are the skid marks? Well, this is going to change things up a little bit. Well, now my speed is 35, and that's going to equal the 30 times the 0.6 for the friction still, and I want to calculate that D. Okay. So to do that, to get rid of the square roots, I'm going to square both sides. So the square and the square root cancel each other out. So square 35 squared gives me 1225. So then that equals 30 times 0.6 times D. Now, I'm just dividing then by what I want. Everything here is being multiplied. So I'm going to divide by what I want to get rid of. 30 times 0.6. Or you can plug that in and you get 18. So 30 times 0.6, or just 18. So again, then this is going to be 68.05, and this 5 is just repeating, and that is going to be the skid mark length in feet. Okay? So the skid mark length in feet, 68 feet, or just over 68 feet. Okay? We got one more question then. What if the speed of the car is doubled? Will the skid be twice as long? Okay? So what if I double it? Well, one way to find out. Well, what if I double it? 35 times 2 gives me 70. Okay? 70 square root 30 times 0.6 times d. So again, now we're going to square again. So we're squaring both sides again. So 70 squared gives me 4,900. And again, this gave me 18, so that canceled. That gave me 18d. So we're then dividing this by 18 again. And d then equals 272.2. So did it just double? No. Okay, it's actually 4 times as much. So 4 times as much. Right? And again, that all comes back to taking this square. When we take this square, it really doubles it. It doesn't double it, it just takes it 2 times 2, or 4 times as much. Okay? Alright, that's your notes for section 3. Graphing radicals.